in a crane, it's obviously a couple loads. When you bring in an excavator, it could be as little as one load. So we like the idea of being able to bring in an excavator, or even maybe use one that's already on the job to drive a couple piles, like let's say less than 25 piles. It makes sense to go in with a smaller machine, even if you have to maybe do a splice on the pile. So a job came up where we had a really tight access and there was no way that we were going to get a crane in there anyway. So it was a little bit of a nudge forward to say, okay, let's go with it. Let's develop a prototype for this excavator pile driving rig and see what happens. So we developed the rig. It looks like what you see on the left here, the left picture. And remember when I talked about the military lead, the reason we were able to put this prototype together quickly is because we actually used the lead sections from that military lead, very lightweight, in order to develop the prototype. So in about 3 weeks, we ended up on this job site with very tight access and drove a small number of piles, but it proved the concept. It proved that we could put an excavator mounted lead for piling together, and made sense that we moved on. So our design goals and parameters. So we wanted to start our initial EML design for the minimum size excavator of 30 ton. We wanted to drive as long a pile as you possibly could so that we could avoid splicing where necessary. And we wanted to ship, obviously, we talked about it, for minimal cost. Now, one of the things we also really wanted to be able to do was to be able to prove piles. So for PDA testing, there's other ways to install piles, but there's only one where you can prove them with PDA testing. So we wanted to make sure that we could prove bridge abutments for at least 1600 kilonewtons with this size of rig. So 1600 ULS, 3200 kilonewton geotechnical resistance. So those were kind of our design criteria. We didn't have to be the fastest way to install these because remember, we're going to smaller jobs, but we wanted to make sure that we had the capacity to prove piles. So from that came the EML30. Now, this picture is actually, again, from the first job that our EML line ever went to. It was in Northern Ontario. And this specific job actually ended up winning the Ontario Road Builders Association's Innovation Award for that year. So a little bit about the excavator mounted leads. This one specifically is the EML30, but the premise for most of them is similar. I'm just going to bring out a little laser pointer here. So you have your lead section. For the EML30, it's 40 feet long. With that, you have an 8,000 pound drop hammer, an anvil, and in the case of the EML30, you can drive a 30-foot pile. Now, in the very first job that it went to, it ended up driving actually a 35-footer, but I'll explain a little bit more about that later. Now, you have your boom point connection, so we're connecting to the boom of the excavator, and we're actually using all of the hydraulics from the stick and bucket circuit at a valve bank where we redirect flow. Now, I want to take a second to explain a little bit about the drop hammer. Now, the drop hammer is held by a line that goes back and over these two sheave blocks. And in between those sheave blocks is a hydraulic cylinder. So when the hydraulic cylinder extends, the lead raises. But then when it retracts, and especially when it retracts very quickly, the hammer drops. That's because all the lines let out very quickly to allow the hammer to fall. Now, a lot of people will ask, okay, why did you guys go with the drop hammer? To which most of the time I'll respond, well, you don't have to. You can go with whatever tool you want to put on the front there. Hydraulic hammer, we mentioned you can go to some drills and stuff for other applications, but you can put a diesel on as well. But if you remember our design criteria, what we wanted to do was to be able to drive as long a pile as possible. Now, drop hammers have the advantage over hydraulic or diesel is that they're very short. So the lead length ends up getting utilized better with a drop hammer in terms of driving a longer pile. Another reason we went with a drop hammer is because we can drop it from higher than your traditional hydraulic hammer would go. So a hydraulic hammer typically has about a 4-foot drop. We can actually use all the mass and drop it from a higher 7-foot to get more energy, and that ties into our goal of proving as much capacity as possible. So this 8,000 pound hammer, we say regularly drop it at 4 feet, no problem, but you can drop it at 7 feet to prove your piles, which gives you a potential energy of 56,000 pounds. So a lot of people might be surprised to find out that even on this little 30-ton excavator, you can hit capacities on the low end of a B32 or a D30. So even on this EML30, you can hit those kinds of capacities. So there's a gate on the bottom. That gate actually completely swings back. So if you have obstructions where the gate would have struggled to open, you can actually even take it off. You can start driving with it on and completely remove it because it's on pins. That actually came out of our first project. So here's a video. Let me just switch off my laser pointer for a second. Showing again that first drive. So you can see barely at the top of there, the shiv block sliding down as if the hammer raises, and then it retracts as it drops. So he's dropping, in this case, from, you can count those holes, about 5 feet. Each of those holes is a foot. And in this case, I think we're driving about a 30-foot 12 by 74 pile. Sorry, on this slide, I also wanted to talk a little bit about the hydraulics. So you can see up at the top, I'll highlight it again with my laser pointer. You can see our valve bank. So everything gets controlled there. You don't need any special aux circuit. We're stealing flow from the stick and bucket. And then we run a electrical control line down and into the cab. Now for our next slide, it'll give you an idea of what the operator takes a look at in the cab. So there'll be a screen. It'll look like a tablet mounted in the cab, and it'll look like this. So this is the operator's view of the back of the lead, and what the operator has attached to the joystick that's already in the cab is this secondary control, secondary joystick. And with that joystick, they select the mode that they want to be in. So if they want to be have the pile winch, they can press this button, and then they'll be controlling the pile winch at the top. Important to note, actually, I should skip back to this video, is up at the top, we have a 12,000-pound winch to act as your auxiliary line. And that's what's helping you load your piles into your anvil and do miscellaneous tasks on the job site. So your controls are all activated by your joystick, and you can see when you activate one of them, the corresponding one on your tablet screen will light up in yellow. So if we had selected the this winch, that would turn out yellow, and you'd know what you were operating, what you were currently moving. Now, one of the great things with the EML30 is that we just knew we had to have side tilt. Now, side tilt, I'll give you an idea of what it looks like with this video, or side leveling. It happened kind of quick in this video, but I'll play it again so you can see it. Going back and forth that little bit. Now, what that allows you to do is, if your excavator isn't perfectly level, it allows you to still just tilt your lead slightly so that you can keep your piles going in straight. So if we had left it fixed, you would have to do things like jack up your tracks by adding fill. It would just be a pain in the butt. So we felt we had to go with this side tilt, and I'll just show you one more time what it looks like. So that is a feature right in the EML30 that you have right off the bat. Another great feature of the EML30 is that you can ship it on the same float as the excavator. Now, some contractors will choose to do it like this to bring it to job sites. Many, we have found, actually will ship their excavator to site previously to do their excavations, and then when they need to do some piling, they'll ship in the lead separately and use the same excavator that was there doing their excavations. Now, the process to change it over, first time we ever did it, it was about a morning on site at that first job. So I think you could get it 3 hours to switch it over. So from the EML45, we move on, from the EML30, we move on to the EML45. Just to give some people some nomenclature there, we say CAT 349, but I'm sure the Volvo guys will let you know exactly what model would go with them. The EML45, we obviously wanted to go a little bit bigger, get a little bit longer a pile, and we also wanted to see if we could get our diesel hammer on it. And spoiler alert, we did. So the EML45, we went up to a 50-foot lead. Let me just bring my laser pointer back. We went up to a 50-foot lead, meaning we could drive a 40-foot pile. We actually upped our hammer mass to go to a 10,000-pound drop hammer. With that, you can prove about 2,000 kilonewton ULS or 4,000 kilonewton geotechnical resistance. So you gain a little bit there as well. And we added a vertical travel cylinder. Now, why this is important is it really assists in lifting the lead up and down so that when you're spotting the pile in location, you don't have to boom down, stick out to be able to keep your lead level. All you have to do is get into place, make sure you're level, and then you can plant the lead straight down. Another thing it also allows you to do is head up over a little bit taller of a pile and tap it until you're ready to plant the lead. So that means that instead of the 40-foot, you can maybe get your 45-foot. Another great feature of the EML45 is that it's diesel hammer ready. So we've mounted our B21 to it. So if you get into projects that are more than that 25 pile project and you want to improve your productivity, you can go to the diesel hammer, which will diesel or hydraulic, which will drive the hammer faster or drive the pile faster. Again, you still have your 3-degree side leveling with the EML45, and all of the controls are very similar. Remember with the diesel hammer, it actually takes up space on the lead, right? So you can only, with the diesel hammer, you can only drive 30-foot sections, maybe 35-foot if you VTL up. So the vertical travel, I wanted to give you guys an idea of what this looks like. So this video should help with that. You can see the lead moving upwards as that cylinder retracts. I'm going to play it again just in case you missed it. Moving the whole thing up. And this next slide kind of gives you a static idea of how high that can go. So in this picture, we have the boom all the way up, and we have the vertical travel cylinder completely retracted. So at that point, I'm pretty sure a 6-foot person could walk under it. Not that they'd want to, but that's how high you're at. So we said the hammers, we said the lead is diesel hammer ready. This is a project that one of our customers was on where they were doing a bridge abutment, and the piles were, I believe, 80 feet long. So they had to do them with a splice and decided there were so many of them. I don't know the exact number, but I think it was upwards of 50, that it made sense to bring in the diesel hammer so that they could drive them quicker. So they did them with the splice and the diesel hammer. And another factor that's important to note on this job was there actually was height restrictions. It was close to an airport, and your traditional set of leads on a crane couldn't actually fit within their height restrictions. So it definitely made even more sense to go to EML with this system. Now, those height restrictions come in pretty important in this next slide, which is our EML45 low headroom. So we had a customer, this development was very customer driven, who needed to drive piles underneath a power line. And they actually had, you can see barely in the background here, if you look closely, the power lines that they had to drive under. And they had a 25-foot height restriction. So our EML coming in at about EML45 coming in at about 52 feet was obviously not going to be within that restriction. So we, at the time of the order, we came up with a way to divide the lead into 2 parts, and our next slide will help show you that. So let me just get my laser pointer again here. So at this point, we came up with a connection that would allow us to basically just use the top half of our EML45 to drive piles in a 23-foot height, overall height. So we disconnected from the boom tip here, made a new connection up at the top, obviously made a connection there, moved the gate up, added a couple more features electronically to be able to control that, and then came up with this system. Now, what's also interesting about this system is it's really a mini pile prover as well. So if you go to a site that needs PDA testing, I know that a lot of sites will actually recall you to go do testing again later in a number of months. So this is a very small unit that you could use to go do PDA testing for piles that you're being recalled to in very remote locations. Another use of that being under pile lines, it's got another use as well. And then you can always go back to your EML45 full length to do your full length piles and use them for that application. Now we have the EML60. So from the 45, we're just consistently getting bigger, and we are taking a look at 60-ton excavators. There's your Volvo 460 for the Volvo guys on the line. In this configuration, we will be driving 50-foot piles with a 60-foot lead. We kept the same hammer mass at 10,000 pounds. Again, you're ready for a diesel hammer, our B21. Difference is now, because you've got a longer mass, you can also do a longer pile with the diesel hammer at 40 feet. That diesel hammer is our B21. Again, you have your 3-degree side leveling, you have your vertical travel, you have your pile, gate, and integrated controls. So the next slide actually shows you all of the line right next to each other. To give you an idea, it's pretty obvious. You see the upward slope here of the leads getting longer and the pile obviously getting longer as you go to the larger excavator. One special application I wanted to show was a special application we did with a 60-ton excavator for low headroom. This was similar to the EML45 in that you could extend it to go to a higher one later, but it was specifically purpose-built to go under this bridge. So this was in Alabama. Piles needed to be vibrated, so that's why you see a vibro on the front of the lead instead of the drop hammer. And you can see through this very special application that we actually developed a swivel on the front of the lead to allow the vibro to be able to go side to side. So there are, like I mentioned at the beginning of the presentation, we have designed custom excavator mounted leads for clients based on their needs, whether it's piling or drilling, CFA systems, direct circulation systems, drilling with air for hard rock, or reverse circulation systems, drilling for with hard rock, or any ground improvement technique you can think of. We have come up with different excavator mounted leads, but the focus of this presentation, let me keep to it, is the pile driving ones. So how will this work for you? It's been used very often. That's actually the EML30 there, driving in some piles for a roadway protection while they were constructing a new bridge. The same lead actually drove the bridge abutments on that same project. You can drive sheets with it as well. There'll be a little bit more explanation of that in a second. Timber pile installations, the lead lengths are very good for timber pile installations. Your typical timber pile between 30 and 40 feet. So EML45 or 30, if you're at the lower end of that height range, is a great tool for that. It's also a great multi-tool. You can mount this lead to your excavator and put any other rotary that you have. We're only really limited by torque to up to 20,000 foot-pounds. So if you have an application that's unique and you do multiple applications and you like to have a jack of all trades rig, this is definitely one of those. So how this will work for you. So what I wanted to do was give you an example project. And for that, I went back to the first project that we ever did with this lead. What it was some roadway protection for a culvert replacement. And what I'm showing with the picture up here is where we installed, that picture was basically installing these piles on this wall. So what we did, partially to help prove that we could drive the sheets in a combi wall configuration, is we did a combi wall configuration and then some soldier pile and lagging as well. And then we did some ties back to some dead man wall on the other side of the road. So this is your one laneway of active traffic, so signal controlled. And then this is the retention system for the roadway protection going in on what would have been the other active lane of traffic. You can see it a little bit better on this slide. You can see the steel H piles that were driven, getting progressively longer as we got closer to the culvert. and the sheet piles that were actually driven in between. So this was a combi wall. The H piles that were driven had interlock installed on them, so that when we drove that pile, and that pile, the H piles, then we drove the sheets in between. You can see from this side, there was a directional driller that came through and put in, drilled those through. The next slide shows you the halfway through the project, so halfway through the excavation. You can see the sheets right there, and the H piles holding them in, and then your H piles and lagging, continuing on. And then the next slide shows you your new culvert section going in and excavated further. So at the end of this, talk a little bit about service. Berminghammer, Hamilton, internationally, it's close to Toronto. For those of you joining us from the States, it's very close to Buffalo, New York. We have experienced service managers and technicians at our disposal that are very experienced in the pile driving world. We have pile drivers themselves that work with our construction team and have lots of experience. And if you have a question, we have a wealth of knowledge that we can draw from. We have spare parts readily available for these setups, the EML45, EML30, and EML60. So if you need anything, it'll be readily available. One other thing that we offer kind of pre-COVID anyway was doing some training. We've done it both on site and in our yard. This is actually one of our trainees learning in his first pile that he did. Just let the video roll here. So this is in our yard. We drove a couple piles so that he could get a hang of it, get a hang of actually lofting the pile as well. Now, in COVID times, what we've been doing is kind of meeting similar to this, just a little bit more interactive. I don't know about you, but it's a little weird just talking to yourself the whole time. So we've hosted meetings where we have basically instructed on how to rig up the evening before, and then check in the morning before with everybody, and done some operator training as well virtually. So most people these days will have a smartphone, and if anyone has a problem, all we do is we hop onto the meeting and take a look and say, okay, that hose, yes, that goes to that. You join it there. That's how we've been helping in COVID, and it's actually worked really well. That whole low headroom system that you saw was done completely virtually. So at this point of the meeting, hopefully, I think I went a little bit long, but hopefully there's still a little bit of time for questions. And if you guys can stay on the line for a little bit, I'll definitely answer. Milan, did you get any questions coming through?
Yeah, there was 4 of them there in the chat. It's not a whole lot. There's about 40 of us on this call, so it's pretty good. Marion had a question about vibratory hammer. That was earlier on. I think that would have been probably addressed with one of the later slides. So the question was just vibratory hammer, and I'm thinking just if it'll be mounted, if she's still on.
Yep, so we can put vibros on this lead. We'd like to talk to you about what size, but yes, we can do it.
All right. Next question, Mohammed. For the side tilt, is it hydraulically operated? Was the question.
Yes, it is. There's a single cylinder that when retracted pushes one way, when extended pushes the other
way. And then Yolanda, how much flow/pressure do you need to deliver a proper functioning of the EML?
So it's a little bit of a roundabout answer to that, but because we're stealing from the stick and bucket circuits, we haven't run into an excavator yet that has enough flow or pressure to do what we need to do.
And the last one we have right now is Justin was asking about, do you recommend the lead to be planted on the ground when driving? So it's more of an operational question.
Yes, it's definitely preferable that it is planted. We find that contractors often push the limit of equipment and will take a little bit longer of a pile than we might recommend, which is why I've just mentioned that. And especially when the softest driving is right at the beginning, you can drive with a lead up in the air. We just wouldn't recommend that you do it very often. And if you are driving with a lead up in the air, you're going to want to have a very small drop. So a tapping really is what you're doing until you get to a place where you can plant the lead.
And oh, sorry.
Go ahead.
William Hazard is asking, you mentioned about take, borrow, steal controller hydraulics from the excavator. What was that detail again, to review that about using the excavator hydraulics?
So, Tyler, you still on the line?
I am, yes.
Yep. You want to
I can certainly do that. 1 second. So the way that we handle this is, first of all, we're taking off the stick, so the bucket circuit is free. It's free for use for this system. So we use the bucket circuit flow for a drop hammer purpose and some other functions. We also use the stick. What we do is we divert the flow from the stick temporarily to do our functions, and then you can activate the stick again from our joystick. So it's more of a diversion on the sticks side of things, and that's all we need. Does that answer your question?
I think it probably does. If I've got this right, I think I've allowed everyone to unmute themselves if they have, if they're the ones asking the question. If they need to comment.
Yeah, I wasn't sure if I could talk. Yeah, that answers the question. Thank you.
All right, awesome.
So yeah, there's no. Go ahead.
Oh,
Another
one more. Pierre Luke snuck in. What is the dimension of your lead? Are they the same as a VTL that goes on a crane?
So specific dimensions. Pierre Luke, they're actually, I believe the section depth is a little bit smaller than the lead that would go on a crane, but it also depends on which leads on which cranes. We have leads L15s that are 15 inches in depth, which would be comparable to this, but we've got leads that are 36 inches in depth too, which wouldn't be. So it's comparable to the smaller end of cranes, but like let's say 70 ton, but not comparable to anything really bigger than that.
I think that gets us caught up with questions, comments, if anyone has any more. Otherwise, we can wrap it up.
No. Just wait a second.
Excellent job, David.
Thank you. Yeah, thanks. I got one more slide here I can run through just to show you guys a little bit more. But thanks, everybody. Hopefully you learned a little bit in this presentation and understand a little bit more about the applications from a piling perspective. I hope to do this in the future to show you a little bit more about the excavator mounted leads we do for other applications, and stay tuned. Berminghammer does a lot of different equipment, vertical travel leads on cranes. We do reverse circulation drilling equipment on a pretty crazy scale, and we look forward to doing a little bit more in terms of presentations like these. So stay tuned, and thanks for coming in.